Okay, now let's look at the weights that we assign in a neural network. So each node in the hidden layer and in the output layer has a theta coefficient. Okay, so we don't have theta coefficient for the input layer. So these theta coefficients are like the intercept in regression analysis. And in the context of neural network, these theta coefficients are called bias values. And then each arrow coming into a node has weights assigned to it. So here there are two arrows coming in, W sub 1,3 and W sub 2,3, and similarly here. And on the other side again, we have weights for W sub 3,6 and W sub 4,6 and W sub 5,6 coming into node 6. Now we start by assigning values for all of these weight coefficients, the bias coefficients and the weight coefficients, in an arbitrary fashion. And the methodology itself will fine-tune these weights to find the best possible weights, as we will see in the example. Okay, so let's start with the weights. Theta weights are typically initialized to random values in the range of minus 0.05 to plus 0.05. In SAS, we can specify that, and SAS will automatically generate these initial weights. So this is like a random prediction, okay, so, or otherwise no predictive value at all. So it's a starting point. It's arbitrarily determined. So you can specify the range from which this random value should be generated. So these initial weights are used in the process of training meaning developing the model. And similarly, the W coefficients, in a similar fashion, the W coefficients are also arbitrarily assigned values. So here, let's assume that we arbitrarily selected values for the hidden layer, okay, nodes 3, 4, and 5. Okay, so we have theta coefficient for node 3, 4, and 5, and then the node arrows coming in from node 1 and from node 2 into 3. These are the weights. And then node 1 to 4, 2 to 4, these are the weights, and 1 to 5, 2 to 5, these are the weights. And on the other side, arrows going out of the hidden layer into the output layer. So again, output layer, there are two nodes, and we have arbitrarily assigned bias values for 6 and 7, and then the weights going in from 3, 4, and 5 into 6, and then 3, 4, and 5 into 7. So if you put all these weights into the network, so this is what the network will look like. So we have weights for each arrow coming out of the input nodes. Then we have biases for the nodes in the hidden layer, and then weights coming into the output layer nodes, and then the biases for the nodes in the output layer. Remember, there is no bias here for the nodes in the input layer. So this is the starting point, and remember, these weights are randomly selected within a narrow range. It can be positive or negative.